Hello and welcome back to another episode of Biology from Jay's House. So hopefully you've been watching all the videos and doing all the homework, and though I didn't collect homework and we didn't go over homework, I know what you guys are thinking. Jay sure talks a lot, but hopefully you just yelled, "What's the point?" We'll see. Okay, let's see what we got here. First thing we're going to do is take some notes, so let's go to the right and write the date. It is I believe this is supposed to be happening on the 23rd. That date might be wrong, so write the correct date if that's wrong. Then drop down a line, go all the way left. We're still talking circulatory system, so hopefully this is in with your circulatory system notes. And let's write the point. And that is, how are arteries veins and capillaries related to highways roads and parking lots. So hopefully reading this, you say, wait, I don't have roads and parking lots inside my body. This must be a metaphor. And you'd be correct. This is a metaphor. So we're going to be talking about traffic, as in out in the real world traffic. And we're going to be talking about the circulatory system, which is inside of our bodies. To truly understand this, we have to remember what the circulatory system is all about. So we're going to use a metaphor of the post office. Hi, I'm a postman. And the postman brings mail to every single house in the world. That's what they do. It doesn't matter what country you're in or where you live. If you write the address and pay the postage, the postman will deliver it. So instead of houses, we'll think about the cells. And this postman, what does he bring? Well, he brings three things. This postman brings oxygen to all the cells in your body. He brings nutrients to all the cells in your body. And he brings water to all the cells in your body. So that's what he's carrying around. And he just goes through your bloodstream, bringing all this stuff. That's his job. So what I don't understand is, how does that relate to arteries and veins and capillaries? Oh, wait. Arteries, veins, and capillaries are the roads that he takes. So the arteries go away from the heart. So if we look at that diagram again, really quickly, and we think of the heart, right? And we remember the heart does not look like an actual heart, even though I'm going to draw it like an actual heart. And there's a top and there's a bottom. Blood comes in and then it heads out on this half of the heart, and blood comes in and it heads out through the bottom of the heart, and it does not pass between, remember? So what happens is the postman carrying, and I've got a smaller one here that'll fit. The postman, which is your blood, enters the heart, and then he exits on this side, and he is off to, if you remember correctly, he's off to the lungs. So let's just draw some lungs. There we go. And why does he go to the lungs? Oh, that's right. So he can pick up oxygen. So when we breathe in, the oxygen is in our lungs. When the blood leaves the heart, it goes to the lungs and it picks up oxygen. Ah, thank you. And now he has oxygen, so he changes color he changes to a deeper red. Technically, blood is always red, but I draw it blue just to kind of keep it visually separate. So he picks up the oxygen from the lungs and he follows it back to the heart. And the heart is just a pump. That just gives him more pressure, power to go to all the cells in your body. So this time, let's go, I don't know, we'll go to your ear. I can give you a little earring. There you go. Let's say you're heading your ear and the blood leaves, goes to your ear, and what does it do? It drops off its air. Here you go. The ear says, thank you. And then it heads back. Now it's blue again because it dropped off its air. And it heads back. Heads back. Gets more power on this side of the heart. Picks up some oxygen from the lungs. Thank you so much. Gets power, goes to all your cells, drops off the oxygen, goes back to the heart, picks up some more power, picks up more air at your lungs, goes back to the heart, drops it off, and just keeps doing that, right? And if we remember, arteries go away. So we have some arteries here. That's an artery. And this is an artery, simply because it goes away from the heart. And the ones that return back are called veins. So that's a vein up there, and this is a vein here, because they go back to your heart. So it's completely defined by direction, not whether it has oxygen or anything else. Okay, now here's the thing is, in these areas, in these arteries and veins, the postman, the blood, is going very, very quickly. He's flying through. In fact, these arteries and veins are like highways and roads. He's going super fast. Go! Woo! Way too fast to actually pick anything up or drop anything off. If you imagine you had forgotten your lunch and you asked your, mom, dad, nanny, whoever kind of does that kind of stuff to drop it off for you, imagine if they held it out the window and drove by and dropped it off. That'd be convenient unless they were on a highway. I gotta go get that. If they're hanging your lunch out the car window and going 65 miles an hour, you are going to end up in the hospital if you try to catch it. Or what if they're on the road and they go, still, it's going to hurt. You're probably not going to end up in the hospital, but you'll get a pretty good bruise at, 25, 30 miles per hour. What you need is you need them to be able to go slowly. Maybe even stop, drop off your lunch, and go slowly. So you don't want to pick up your lunch if your parents are on a highway or a road. It's just too fast for you to pick up your lunch. Also too fast for you to hand anything if you had to hand them a form. But a parking lot, ding, 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 ding. A parking lot is perfect for that. I mean, if they went slow enough, they wouldn't even have to necessarily stop the car. If you imagine being back at Stanbridge, if they just slowly drove through the parking lot, you could grab your lunch, drop off the form, have a nice conversation. Okay, love you. Thank you so much for stopping your life and dropping off my lunch. Bye. And they could continue on. So arteries and veins are like highways and roads. They're super fast moving. So then what are the parking lots? Where are the places where things go slowly? And the answer is, well, it's a thing we haven't used yet. The answer is capillaries. Capillaries are tiny. Blood comes in and chooses a route. comes in and chooses a route, comes in and chooses a route. And here is like the parking lot. Here in the capillaries, in these tiny blood vessels, that's where blood goes slow enough to be able to drop stuff off and pick stuff up. Same thing here. You'd have capillaries here also. So if we think back to our postman, and remember, he drops off oxygen. He also drops off water and nutrients. So he's got all of this in his bag. When he first leaves the heart, going to the lungs, he's going very quickly. He's on a highway or he's on a road. Wow, there's a lot of pressure coming out of the heart. Holy cow. And then he gets into these tiny, tiny capillaries. And there he goes very, very slowly. Definitely slowly enough to pick up some oxygen. Slow, slow, slow. He gets in a vein. He starts moving fast again. This is like a road or a highway back to the heart. Then in the heart, whoosh, he goes flying out in this artery, which again is like a road or a highway. And it's not till he gets to the capillary that he goes slow, 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 to the point where you can ask your ear, hey, ear, you want some oxygen? Sure. There you go. Hey, you want some nutrients? Sure. Here you go. You want some water? No, I'm all set. Okay. And then whoosh, it goes back into the vein. Whoom. Veins again are like highways and roads. And off he goes. Flies through, hits a capillary, goes slow, slow, slow. Slow enough to be able to pick stuff up. Hits a vein, hits an artery. Slow, slow, slow. Slow enough to drop something off. And then whoom. Slow, slow, slow. Slow enough to pick something up. Whoom. Slow, slow, slow. Slow enough to drop something off. Whoom. And around it goes. So both arteries and veins are like highways and roads. You have large arteries and veins, like the ones right by your heart, which are huge. They're very wide. Those are like highways. You have smaller ones that are leading into the capillaries. So those would be the arteries and veins that are kind of here or leading out of the capillaries here. Those are like roads where blood is moving pretty quickly, but not highway fast. But it's only in the capillaries where blood goes so slowly that it can pick up stuff, drop off stuff, or even stop. It is very normal for blood to periodically stop in your capillaries. If blood stops in your artery or your vein, either artery or vein, that's a really bad day. You don't want that. But if it stops in your capillaries, it's fine. Just like if traffic stops in a parking lot, well, that's very normal, especially during like drop off and pickup at Stanbridge. If it stops on a road, oh, that's really annoying, right? If it stops on a highway, you got a bad day, especially if you were going 65 miles an hour. So we can think of arteries and veins as roads and highways, right? And we can think of capillaries as parking lots. Now, I have a video queued up. I don't know how well this is going to translate. Wish me luck. I think the best way to do this is literally just show you my laptop. So here's a super low budget way of us watching a video together. So what you're going to see is actual blood passing through. So just to kind of talk about this picture, here is a major artery or vein. Here is a major artery or vein. You have these kind of thicker bits are also arteries and veins. And this is an actual image of blood pumping through. And if we watch, while it thinks and buffers, you can see how fast the blood is moving. Holy cow, it's going super fast through these arteries and veins. That's like a highway, right? And you can see here, it's kind of, this is like a road and that's like a highway. So arteries and veins, roads and highways, all that good stuff. The stuff we were talking about. I want to go back and watch that again. So this is like a highway. This is like a road. These are your arteries and veins. Okay, but where are the capillaries? I don't see the capillaries in this video. Well, we're going to go back a little bit. Capillaries are here. If you watch very closely right here, you'll see blood coming in. You'll see it going very slowly. Occasionally it even stops. So let's watch that segment again. Right there. It goes quickly and then it stops. And then it moves and then it stops. That's a capillary right there. Right in that video right there. That is a capillary, and that is like a parking lot. Going back, I'm sorry. That is where blood goes. Sorry, I gotta hit play. That is where blood goes so slowly that it can pick up stuff from the cell, drop off stuff to the cell. It is in those capillaries right there that blood goes slow enough to actually do its job. So one last view. Highway, road, these are arteries and veins. Capillary right there. Look at how slow that is. It even occasionally stops. So that is real life footage. That's the exact thing that we are talking about. So I want to get into this. So again, these arteries and veins, these are the highways and the roads. That's where blood goes really fast. It's only in these tiny capillaries that blood goes slow enough to drop off stuff or pick up stuff. Otherwise, it's just too fast. Now, there is a note that we did not take at the beginning of class because I wanted to get into this. So we're going to take a note right now. I'm going to erase this. So if you want, you can pause the video or go back if you need that picture again. And I just want to remind you that fast, right? And parking lots are slow. Oh, I need a new green marker. Okay, so the note is, in each unit of the human body, I like to talk about something you should eat to kind of help that system. And for the circulatory system, I like to talk about iron. Iron is something that you should eat. And it is the part of food that helps blood carry oxygen. We talked very briefly about how there's a protein called hemoglobin, and hemoglobin allows your red blood cells to carry oxygen. Since red blood cells are, well, cells, I mean, that's what they are. Your red blood cells cannot actually carry oxygen. They can't, like, pick it up, right? They are, well, red blood cells. Any more than I would be able to grab it with my skin cells, right? I can't grab oxygen, hold on to it, and put it in my pocket. And since red blood cells carry air, how do they do that? Well, it turns out they use a protein called hemoglobin, and hemoglobin uses a bunch of iron to do its job. So what really happens is hemoglobin grabs iron, iron grabs oxygen. So it's actually kind of it's a little more, this oxygen, your red blood cells, they grab hemoglobin, and hemoglobin grabs iron, and iron grabs oxygen. So it actually requires two middlemen for red blood cells to do their job. But you can't eat hemoglobin, that's a protein, we make it, right? But you can't eat iron, that's a thing. Iron, stereotypically, you find that in two really normal foods to eat. One is dark veggies. That's your kale, that's your spinach. Any really dark green veggie gives you tons of iron. So put a lot of spinach and kale and that kind of stuff in your diet and you'll be happy. The other one is red meat. So if you eat a lot of beef, you'll get a lot of iron. eat a lot of red beef, you may have problems. But putting dark veggies and red meat in your diet, or just a lot of dark veggies if you don't eat meat, will give you the iron you need. And that will help your red blood cells carry the oxygen it needs. So, and just a quick reminder, so when we look at blood being separated, the only thing we're talking about now is this part down here, the red blood cells. We're not talking about the plasma or the white blood cells and platelets. It's just this part that needs iron to be able to carry oxygen. Okay, well, I think that's all I've got for you today. So let's answer the point. And if you need this, just pause the video and copy it, right? Or go back and copy it. So let's answer the point. And that is, hopefully you're all yelling out the answer. How are arteries, veins, and capillaries related to highways, roads, and parking lots? The answer is arteries and veins are like, that's a K, it's not super obvious. Highways and roads because blood moves quickly through them. Way too quickly to do anything. When blood is in arteries and veins, it's just trying to get somewhere. That's all it's trying to do. It's not dropping anything off. It's not picking anything up. It's literally just getting to that part of your body. It's getting to your feet, getting to your fingers, getting to your liver, getting wherever. That's what arteries and veins do. They just get blood where it needs to go. Capillaries are like parking lots because blood moves slowly through them. And it's in the capillaries that blood does its job. It's in the capillaries that the postman can either drop off or pick up water, that the postman can either drop off or pick up nutrients, that the postman can either drop off or pick up oxygen. It's only in the capillaries that they can actually do your job. So this is where it goes slow enough to pick stuff up and drop stuff off. So your blood takes arteries and veins just to get there. And then it goes into tiny capillaries to actually do its job. There it is. I'll see you tomorrow for more biology from Jay's house.